and Sustainable Development in Africa, applicable to Egypt and South Africa, by testing the relationship between independent variables represented in urbanization level and the urban population, which represent urbanization indicator, and the dependent variables represented in GDP per capita and CO2 emission and the life expectancy at birth, which represents sustainable development according to availability of data within a time period 1990 until 2020. In both Egypt and South Africa, by using the modern scientific method. Data sources World Bank database, World Bank Economic Development reports until 2020, United Nations reports until 2020. This slide shows the first variable, urbanization level, and the urban population. These are the independent variables. And the second, this GDP per capita and the CO2 emissions and the life expectancy at birth. This is dependent variables. Results in the short run and in long run, there is a significant relationship between GDP per capita and the life expectancy and the CO2 emissions and the urbanization indicators, where the value of R square reached about 90% and 90% and 63% in order. In South Africa, in short run, there is a significant relationship between GDP per capita and life expectancy and the CO2 emission and the urbanization indicator, where the value of R square reached 96% and 99% and 31% in order. But in long run, there is no significant relationship between GDP per capita and urbanization indicators. That means no integration relationship. Recommendation of this study, that necessity of relying on less air polluting means of transportation in Egypt and South Africa. Increasing the interest of South Africa in the industrialization and innovation and smart cities in order to achieve urbanization. When going to urbanization, it should rely on clear and planned strategies in order to benefit from urbanization advantages and not rely on random plans. This is evident in the urbanization strategy in South Africa, which aims to civilize coastal cities without going into the continental mass of the country. This evident. Sorry, thank you. Thank you.
Thank you very much indeed, Dr. Amani. It was really for respecting the time and keeping the time. I wasn't able even to say 2 minutes left for you. You are really keeping the time, and I hope everybody follow your steps on keeping the time. Thank you very much indeed once more, Dr. Amani, for keeping the time and observing the time, and for a brilliant presentation where you give us a comparative study between South Africa and Egypt. Thank you very much indeed. You are so kind. Thank you. Colleagues, I'm trying to save the time of the session. I'm still waiting for the first 3 presenters to come on board, but yet they are not able to connect. So I may call upon Dr. Ayman Abdelhamid to give us his presentation. If it is possible, Dr. Ayman, and you are ready, we welcome you to the floor.
Thank you very much.
Thank you, Dr. Ayman. Please, you have the floor. You have 10 minutes from now. Thank you.
Okay. Okay, so do you see my screen?
Crystal clear. Thank you.
Very, very clear indeed, indeed clear.
Okay, thank you very much. So my presentation, it's about converting Egyptian commercial building to net zero energy building using low carbon measures. This work has been conducted by me and Engineer Mu'taz and Professor Muhammad. So first of all, we would like to introduce something about the energy demand and how much energy consumed or delivered to the building sector. So here, some statistical data about how much electricity demand in Egypt in 2019. It reaches to 142 terawatt hour with annual average rate of growth by 5%. And the building sectors has the large contribution of this demand by around 70% at the same year. And also the peak load increased by about 2% from 2018 and from 2017 to 2018. Originally, I would like to say we interesting in research topics related to the techno-economic environmental effects of low carbon measures on the building sector, whatever it's new or existing residential or non-residential building, aiming to update the current version of the National Building and the Energy Efficiency Code for Egypt. Also, we would like to participate in achieving Energy Vision 2030, especially regarding energy bill. So the work I will present now, it has these objectives. The objective is to evaluate the low carbon measures on existing administration building in Egypt to reduce both energy and greenhouse gas emission, and also evaluate the visibility of applying these kinds of measures. So the selected building here, it's owned by Ministry of Communication and Information Technology, located in Maadi City in Egypt, in Cairo, and it's used as a call center office building. It's 7th floor with total floor area 25,000 square meter, and the occupied area or the portion of the air-conditioned area, it's around 77%, and the rest is unconditioned according to the usage. So we here used the simulation technique to simulate the building and evaluate all aspects. And we used mainly Open Studio and Energy Plus tool. So here we can see the construction of the building, and the existing building envelope thermal characteristics were obtained from the design package. And the construction of the external wall consists of sandstone and air gap insulation board and so on, with the corresponding U value. It's around 0.28 watts per meter square Kelvin. The glazing has a solar heat gain coefficient of 0.3, and the overall MDU value around 1.44 watt per meter square Kelvin. And the glazing has window-to-wall ratio of 25%. Here is some information about the spaces and gains in the building. So we have here 251 space. The total occupancy in per shift, it's around 3,100 person. We have here 3 shifts, so the building it's always occupied at 24 per hour, 7 days per week. So the people density it's around 8 meters square per person. Lighting schedule and the values it's shown here in the table blue. Also, we take into consideration all heat gain from the electrical equipment and the ventilation, and also taking into account the schedule for each activity and for each gain, like lighting, ventilation, and so on. So here also we show you some schedules for the call center area, the occupancy schedule along the day, and also training room occupancy schedule along the day, and so on. These values changes from work day to weekend or vacation day. So let's go to the result. Here's the annual result for the space cooling in the left and the right, and the space heating is right. So we can now see something like the space cooling demand reaches to around 50 watt per meter square in the summer, and the heating demand it's quite small, only 1.2 watt per meter square in the winter. If we look into the monthly and annual demands, so we can see here the breakdown for the equipment demand, lighting, electrical demand, heating and cooling, and the summation of all in the black points. And this result compared with the actual consumption obtained from the electrical meters fed the building, and there is a good agreement with the average error around 2%, and maximum error it's around 8%. If we look onto the annual value, the annual amount of the demands, we have here the cooling demand, which has the largest portion, and also here we have the equipment and lighting, and the very small amount of heating load. So after the validation, we went to how to develop or how to reduce this energy demand. So here we suggested 7 alternative glazing types rather than the base model, and simulate this to achieve or to get how much reduction we will found. So here's the characteristic of the 7 types, and also the first one is the base model data. And here the amount of the cooling demand in kilowatt hour per meter square annual for each type. And of course, we can see type 7 has the largest energy saving regarding the cooling. However, it's increased the heating demand, but the heating demand it's already very small amount. So changing the glazing in the base model to the type 7 with these characteristics will reduce the overall demand of the building by amount 11%. Also, when we change or focusing on the lighting fixture and using LED light here compared with other types in the market, we found that the LED light, and this is of course common knowledge or information, all of us know that LED light with high efficacy lighting will achieve the minimum energy demand, and this and reduce the cooling demand by around 8%. However, it also increase the heating demand by 5%, but this amount is very, very small, and reduce also the electrical lighting demand by around 45%.
Dr. Ivan, 2 minutes, please.
Okay, so I almost finished. After that, we just collect the best alternative from each measure and model and make model for that. And after that, we added a photovoltaic panel on the roof to reduce the delivered energy to the building. So in the conclusion, we can say that replacing the base model glazing type to type 7 will reduce the energy demand. Also, using LED light will provide energy or electrical demand saving by around 45%. This modification has a payback period of 3.15 3 years or approximately 3 years without photovoltaic panel. But after adding the photovoltaic panel, we can found the payback period. It's around 4.4 year as a payback period. So this is what I have, and thank you very much for listening.
Thank you very much indeed, Dr. Ivan. There is a lot of ideas and information given in your presentation, especially when we save energy 37% and the payback is almost 4 years. This is something really appreciated, and we are happy to have you among the papers are presented in this session.
Thank you very much.
Thank you very much indeed, Dr. Ivan. Colleagues who give their presentations during this session and others to come, please share with us your presentation so we will be able to upload it to the website where other colleagues can benefit from it and to engage with you in more discussion for future cooperation. I'm delighted to be here today with you in this particular session on ECHO 1, but as I stated, I merge ECHO 1 and ECHO 2. I take some colleagues from here, some presenters from here and there because of the connectivity and because this conference, as you know, is virtual and there is a lot of challenges being virtual. According to the schedule, we have 5 presentations and then we will have a discussion. So I call upon all the presenters who join me in this session, Professor Sangan, Professor Amani, and Professor Sassani Glazing, and Dr. Ayman Abdelhamid. Don't go anywhere because we are open the floor for discussion. So colleagues, participants in this distinguished meeting or this August meeting, the floor is open for discussion. Please raise your hand if you have any point to raise or to discuss. Colleagues who are participating physically in Al-Abur Institute, kindly communicate with our moderator to take the floor from that end. Thank you very much indeed. The floor is open. Professor Ali, oh yes, Professor Ali, I forget you, sir. I'm very sorry. Also, Professor Ali presentation is with us. Thank you, Professor Ali. Unless you're requesting the floor to ask a question or to put a clarities. Professor Ali? I don't see any hands except Professor Ali, Wadi Muhammad, El Amin. Okay, please, you have the floor. You put your question.
Thank you so much. These presentations were actually very, very good. Answering to today's challenges with urbanization. I just had a question for, now the names are difficult for me. My name is Eni Muchelemba from Zambia. So greetings from Zambia, Lusaka. I had a question for the presenter who presented on water scarcity. I see a different trend where we see population growth in the rural area. I just wanted to find out what could be the factors contributing to this. And then I also had a question from the presentation on wastewater treatment from Khartoum. I noticed that only 6% of the 802,000 cubic meters of water produced is treated using sewer. Are they, meaning that 94% is non-sewered? Have they embraced fecal sludge management? Because that's a large quantity that has to be dealt with. And then I just wanted to appreciate the presentation by the one that's using hibiscus. I think he's from Chennai. I think this is consistent with today's progression in filtration, where we need to move from the traditional sand filters to activated carbon. And he has already demonstrated how activated carbon takes out a lot of pollutants, especially micropollutants, which if you're using surface water, and with the industrialization we have seen over the years, really our water treatment processes need to evolve. And he has just demonstrated that activated carbon is one of the options we have for filtration if we are going to increase life expectancy. I am a water supply and sanitation engineer, and I remember very well Professor saying one of the objectives of water treatment is to increase life expectancy. And so the more pollutants you remove from water, then you are pushing the life expectancy above. And he said, I trained in Netherlands. That's why I did my master's. And he says it's not surprising to find developed countries have a high life expectancy because their water treatment evolves with response to pollution. So they try to tackle pollutants as they emerge so that they adhere to increasing life expectancy. Thank you. That's my submission. Thank you.
Thank you very much, Annie from Lusaka, and greetings to Lusaka from Abuja here, and the headquarters of the ASRIC and African Union Scientific Technical Research Commission. And thank you for being with us and for your contribution and questions that are going to increase the understanding and improve the presentation we had. Also, I would like to bring to your attention that we are having filters when you are using Moringa sand filters, which you may need to read the publication in the website of the ASRIC, and then we will be happy to receive your comments. Before giving, I think Abdurrahman Amin,
Yes,
he raising his hand to ask a question. So Abdurrahman, you have the floor, please.
Thank you very much, sir. It's not a question, but contribution to what the last speaker just said, and to bring about some clarifications, because at this gathering, we must ensure that people are not misled. What the presenter presented is secondary treatment. Yes, classifications in water treatment. That is secondary treatment of water treatment. But when it comes to the primary treatment, depend on the type of filtration system. There are different types of filtration system when you talk of rapid sand filter system. We have the normal rapid sand, we have the pressure type. So, and it goes along with chlorination, except if the system has a defect. It still remains, to me personally, if the system is not having issue, the municipality operation method of producing water still stands out to be the best if other things are constant. Reason being that the water that you produce through municipality operation has high degree of mineralization, and of course is free of pathogen if it is well chlorinated and the system is intact, that is, if the pipes are not exposed. And when you look at the water chain from the treatment plant down to the consumer, there is no any physical contact. Now, coming to secondary treatment, when you talk of the use of
Abdurrahman, thank you. I think you need to go to the point and put your question clear so we can have a response from the presenter.
Okay, sir.
Sorry, because the time, I hope we have coffee break.
I was just trying to
I was going to say you can sit with Professor Sassani and you discuss together in the coffee break, but we don't have a coffee break here. So just go to the question and make my life easy. Thank you.
Okay, sir. Now, the questions is that for the use of activated carbon, of course, it's better, but it has a disadvantage. The disadvantage is that there may be some introductions which needs to be removed using reverse osmosis. And when you use reverse osmosis, all the nutrients are removed from the water. And that is the area I want us to look into. Except the water is remineralized. And that was why I say it's not a question, but a contribution. Thank you for giving me the opportunity.
Professor Abdulrahman, I think we benefit from this contribution, and I believe we will be happy to have further discussion in this issue of water, because we are going to have a very soon a meeting on the water to discuss about these issues of water. Thank you very much for giving your opinion. I see no more other hands.
Yeah, I have question, Dr. Hamdi.
Professor Ali.
Yes, I have question.
You have a question or you are going to have a comment?
I have a question to Professor. Shukran. To Professor Sinan, I would like to ask about the efficiency of these techniques. I think that you made analysis before entering this system and after. I think I would like to see the effectiveness of biocarbon. The second question I would like to ask about the quantity I needed from the hibiscus rose to produce, for example, kilogram of biocarbon, and the quantity of biocarbon to treat, for example, cubic meters of these waters. Thanks.
This is great. I'm so happy really to moderate this meeting, and I believe the papers presented to us is very interactive, and that they create a lot of discussions. But I'm going to stop the discussions here. I'm not going to take any hands to be raised because of the time, and I believe I will give each presenter 1 or 2 minutes to conclude, to respond to some of the points being highlighted, to save the meeting time. I will not repeat the questions. I believe every presenter has captured some of the points he or she would like to respond for. So I will start with Professor Sangan from India, and I believe there are many questions came to you, Prof. So you have the floor, please. Colleagues, please lower your hands.
Yes, sir. Yes, sir. I am here to address the questions of my colleagues. Thank you very much. I am also part of African research group. I was from Africa from 2004 to 2009 in Ethiopia. I'm very happy to address all these issues. First of all, I wish to clarify that This is not an activated carbon. Number one, activated carbon is different from this. So this is named as biocarbon, a substituent material. It is actually a substituent material, very cheap material, which can be produced from any plant leaves. The one important condition here is the selection of plant leaves are very important. All the plant leaves cannot be used for producing this biocarbon. So we have certain criteria to select the proper plant leaves for the production of this biocarbon. So this biocarbon is literally very cheap, and also quantitatively it works for the removal of various heavy metals as well as other organic pollutants. With respect to cost, it has to be analyzed. So whatever we are doing in our laboratory, it is a pilot scale research. So first we started from the removal of fluoride, one end, then extended towards the removal of noted heavy metals. Then we come across for the removal of organic pollutants, bulk organic pollutants in the wastewater systems. So it is a broad spectrum area where this biocarbon is working well. So it can be effectively used for the treatment of any type of industrial wastewater. So what I'm going to give you here is the quantity of removal is excellent, as well as quality is also excellent. At the same time, the analysis of cost is very important. So still we are working on the cost quality. So that is in the question.
Thank you very much indeed, Professor Saote. I believe Professor Abdurrahman and our colleague, Professor Irina, they can communicate with Professor Sangan and your good self by email. I see the email of Professor Sangan. You kindly put it for us on the chat. So we can stop here and the discussion could be continued. And I believe the African Union Scientific and Technical Research Commission and the Obor Institute will benefit a lot from the output of this discussion, along with our beloved continent, Africa. Now I call upon Amani Salah, Dr. Amani Salah, if she have any comments or to add something before I close this session. I see there is no comments from Dr. Amani. And I believe Dr. Amani is attending from the gathering on Al Obor Institute. So thank you very much, Dr. Amani, for your presentation. I go for my brother, Ali Wadi Muhammad Al-Amin.
Okay, thank you, Dr. Hamdi.
Thank you.
Yeah, I think I would like to highlight for the huge amount of water really generated in Khartoum state. Only 6% that under the management of Khartoum Wastewater Corporation. Really, we are facing a big problem that most of the water not reaching the treatment plants. All this water dumped around the cities really represent a big problem. If through my presentation, I have some pictures about this type of dumping around the cities. Now the authorities are working to construct another treatment plants in Omdurman and Bahri. I think this will deal with this problem. But I think we need also to utilize these waters in irrigation as to save our fresh water. Because in the past or in the few years ago, they discharge this water into the Nile. And this is really big problem because the Nile is represent for us for life. Yeah. Therefore, if we find a way for this water to be used in agriculture, for example, I think we will save our fresh water. Thanks.
Thank you very much indeed, Professor Dr. Ali. And let me tell you something, the issue of dumping water upstream and downstream, I think the intake of the water should be downstream for any factory and the dumping should be upstream. So if they able to purify the water and make a good quality water before dumping it to the river, they are the one to take the water back to their factory. So this is again some way or somehow we can able to ensure that the chemicals are and the industrial waste that dump into our rivers are not going only to the people, but also the industries who are dumping these things will suffer unless they are really working on the water treatment of their the industrial waste. Now I go to Sasani Blessing, please, if you have any comments on 1 minute.
Okay, good afternoon. I think the question posed to me is what is responsible for population growth in the rural area? I think the first thing, an answer to that will be the birth rate helped in the increase of population, and also urban expansion, because the urban areas are getting filled up. So most people are moving from the urban centers to the rural areas, especially when these estates and land vendors, when they sell lands in the rural area. So some people in the rural areas tend to, in the urban areas, tend to build in the rural areas, and that is increasing the population in the rural areas. But if rural area population is increasing and there is no water, then that is a time bomb, which might explode at any time. So the need for the research. Thank you very much.
Thank you very much indeed. I think we finally with Dr. Ayman Abdul Hamid. If you have any comments. Colleagues, thank you very much indeed. I think there is no comments from Dr. Ayman Abdul Hamid. And
Hello, sir.
Yes, please.
Yes, I have issues on that. The death rate. Of course, from my own research, research has shown that the urban environment is now highly polluted with persistent organic pollutant, which is otherwise known as emerging pollutant. They have been in existence, but simply because there is little or no awareness. It's of recent that when the rate of death is getting higher in the urban environment, even in the rural environment, that has actually accounted for high death rate, most especially in developing countries, where facilities and equipment that can take care, or probably the way the structures are organized, that can take care of these emerging pollutants, they are usually in liquid, solid, and gaseous state. In fact, the most dangerous aspect of it is the gaseous type, which are otherwise referred to as volatile organic matter. I mean, VOC, volatile organic material. So, I believe personally, the government of the day are not living up to expectation. Because if you take statistic data of most of the West African countries, from what I've searched, there's serious
Professor Abdurrahman,
Yes,
Abdurrahman, I mean, sorry to stop you here, sir, but what you are saying for me is a matter of great interest. And in the level of ASRIC, we have a project on water. And I believe after this meeting, we need to have a Zoom to discuss together on this upcoming meeting in water. And I call upon all the colleagues who are interested in the issue of water to write to the Secretariat, because I believe by next month, we will have a roundtable discussion on this issue of water, because as you said, water is the life and people are suffer a lot. The average lifetime of African is depending on the quality of water we are consuming. and the quality of water we are irrigating our agriculture. I totally agree with you. The chair of ASRIC himself, Professor Ratemo Michiaka, is very interesting, along with the Bureau of ASRIC. And therefore, I'm stopping you here, Prof, because we need to have a real roundtable discussion. And I promise you, before the end of September, we are going to sit up together, all those interested in water in this meeting, to have more and brilliant discussion over 1 or 2 days in this aspect of water, because it's one of our flagship projects. And I'm sorry to stop you here because I need to hand over to the next chair. And I know the discussion is very interesting. Professor Abdurrahman, please send us the email. Those colleagues are interested in water. Make the subject is water in Africa for better life. And we will be happy to receive it and set up a round table to discuss more and more in this issue, because we can't tackle all the problems. I thank all the presenters. I thank all the interventions we had, because this means we are Africa, we understand the problems of our continent, and now it's time to put the hands together to find the solution to solve our Africa problems by our African talent. Thank you, colleagues, members of this session who participated actively, and all the audience for this session. Colleagues, at this junction, I'm really delighted to hand over to Professor Khalid Al-Bahnasawi. Professor Khalid, I hope you take over from me. And I sent you that we dealt with some of the session is mixed now. You have the first three. You have the first 3 in the Echo 1, and you have the last 2 in the Echo 2, and Echo 3 all are free. So whenever you are able to collect 5 presenters, you break and start your discussion. Professor Khalid, I'm delighted that we work together in the organizing committee to have this success. And I believe you can see the successes happening throughout all this discussion and brilliant participation of our African brothers and sisters scientists. Thank you very much. It's over to you, Professor Khalid, for taking over. Thank you.
Okay, thank you, Dr. Ahmed. Now we have last two people. The first one, Saad Sayed, an efficient analysis of ad hoc on demand distance vector routing protocol at different transmitted power and speed. Dr. Saad Sayed, my colleague, we must stick to the exact time. The time allowed 10 minutes.
السلام عليكم ورحمة الله وبركاته.
عليكم السلام.
My name is my paper entitled An Efficient Analysis of Ad Hoc On-Demand Distance Vector Routing at Different Transmitted Power and Speeds. We divide our presentation into introduction, then objective, method used, simulation parameters, simulation results, finally conclusion and future work. Introduction, mobile ad hoc network or MANET is a dynamic system which is totally free of fixed infrastructure, which is supported by wireless communication technologies such as Wi-Fi, Zigbee, WiMAX. Features of ad hoc networks: no fixed network infrastructure, deployed as multi-hop packet network rapidly and low expense. In MANET, each node is responsible for routing its data according to a specific routing protocol. We can classify it the routing protocols in minute into 3 categories. The first one, proactive. The second, reactive routing protocols. And the third, hybrid routing protocols. The first one is built frequently by a routing table. So it's also called table-driven routing. The second, reactive routing protocol, no predefined routing table. The routing is establishment on demand dynamically with the request of packets. Based on the response, the next node is identified. This process goes until fixed path is established. So this category is also called on-demanding routing protocol. The third is hybrid. It's a mix of both proactive and reactive routing protocols. Some examples of protocols of proactive routing protocols: DSDV, destination sequence distance vector; GSR, global state routing; OLSR, optimized link state routing. Some examples of reactive routing protocols: AODV, ad hoc on demand distance vector. This is the selected routing protocol in our work. The second, TSR, dynamic source routing protocol. The third, TURA, temporary order routing algorithm. Some examples of hybrid: DDR, DST, ZRB, zone routing protocols. Overview of selected routing protocols. Ad hoc on demand distance vector routing protocol is one from the reactive routing protocols that maintains routing only between nodes that need to communicate. Features of our protocol: routing message have small packets size compared to other protocols. Then routing with the shortest path. Use sequence number to specify how fresh route is. Operation of protocol: discovery of routing, then set up the routing, then maintenance the routing table until the communication session is ended. Objective of our paper: performance analysis of the selected routing protocol at different transmission power and speeds using OpNet simulator. Method used: create a campus network of required size, then add mobile nodes, then assign internet protocol version 4, then assign our protocol, then setting the application what data is transfers between nodes. Then deploying traffic on the simulated network, then mobility configuration. Simulation parameters: we select simulation area, then routing protocol. Transmitted power varies between 1 dBm to 4 dBm. Node speeds examined at 10 meters per second and 20 meters per second, 30 meters per second and 40 meters per second. Simulation time 1 hour. Network size: we perform our simulation in 2 network size, 40 nodes and 80 nodes. Mobility model: random waypoint mobility model, RWMM. Simulation results: according to results obtained from OpNet simulator, the maximum throughput achieved 2 dBm in network size 40 node and speed 10 meters per second. The average throughput is around 300 kilobit per second. The second results: at 20 meters per second, the maximum throughput achieved at 3 dBm. At 30 meters per second, the maximum throughput achieved at 2 dBm. At 40 meters per second, the maximum throughput achieved at 1.5 dBm. The second performance metrics selected, end-to-end delay. We evaluate our simulated network by two metrics, throughput and end-to-end delay. The end-to-end delay, the minimum end-to-end delay achieved at 1.5 dBm and speed 10 meters per second. The minimum delay achieved at 1 dBm is 1.1 milliseconds for 20 meter per second speed. And so on. We perform simulation for 58 scenarios, combination between different speeds and different transmitted power. Comparative analysis between simulated scenarios. We show 1.5 dBm transmitted power achieves low delay in case of 40 meters per second speed. So the optimum transmitted power in this case is 1.5 dBm, which has maximum throughput and low end-to-end delay. These results different from the others from the point of network size, 80 node network size. We show 1.5 dBm transmitted power achieves low delay. Conclusion and future work. The results show that the throughput increases as the transmission power increases up to certain value, after which the throughput decreases. The throughput decreases due to increasing of interference. The designed routing protocol, AODV routing protocol, for 40 nodes managed network performs optimally at transmission power of 2 dBm at speeds 10 and 30 meters per second. The optimal transmitted power is achieved at 3 dBm and 1.5 dBm at speeds 20 and 40 meters per second respectively. The maximum throughput can be achieved at 2 dBm at speeds 10, 20, and 30 meters per second for 80 node network size. This work will help the network designers in selecting various network parameters such as optimum transmission power and network size. This work can be extended to evaluate routing protocols such as DSR, DSDV, and OLSR. Evaluate the selected protocol at different applications. Thanks.
Okay, any question about Saad Said? Okay. The next one, Professor Muhammad Salah Fathi Az, suburban zero energy building using green architecture application.
Good evening. My name is Dr. Muhammad Salah, lecturer in the architecture department, zero energy. Zero energy building, green architecture. Global warming and climate change are rising issues during the last couple of the decades and in the last 20 years, with residual and commercial building being as the largest energy consumers and the source are being depleted at the much faster pace in the recent of the last 20 years. Green architecture is a general term that describes environmental inclusion design techniques in the field of architecture. It is the process of designing a building in a manner that respects the environmental taking in our account, and that the main goal of this using this technique to decrease the consuming the energy. The building material for green architecture offer many advantages of the owner of this building. First advantage is reducing the maintenance and replacement cost over the life of this building, and realizing energy and the improving of the earth. Improving the health and the productivity of the residents. Criteria of selection: green architecture, material or products, source efficiency, indoor air quality and energy efficiency, and availability. Definition of zero energy: these techniques have many shortcuts like ZEB or Z or NZE or ZNE. It means the building or energy consumption of the energy and total amount of energy used by the building on the annual basis to equal to the amount of renewable energy created on the site, or in another definitions by renewable energy sources outside. Using technology such as heat pumps and high efficiency windows and good isolations and the solar panels. Example for using this technique to provide the energy for the building and to be economic for using the energy. Stiffness library at the separate earth building. It is located in the California, USA. It is elementary and high school, and this type of this project is very good candidates for achieving the goal for this techniques: zero net energy or zero energy by using the design and performance, because they are in generally one or two stories in height with good opportunities for daylighting and sufficient roof area for the right size solar photovoltaic system. This building is seeking to have the qualification or certification from when they net zero energy building certification under the Living Building Challenge. It is also being monitored by the third party measurement and verification and team under the Zero Net Energy Program. Design strategy for Stiffness library: the site is designed to maximize passive solar orientation, daylight and natural ventilation, solar harvesting through solar panels. The photovoltaic system provides all the library needs from the energy. High performance glazing and added rigid good isolation for the building and to reduce the energy loads. Native also when using the water will be native drought tolerant plants are water used by the harvested rainwater. This is some picture from the library. So, the conclusion: the green building aim to maintain a balance between the building and the surrounding environmental, as the building protects the human being from any climate conditions or changes that may occur when the building doesn't harm the environmental navigation or consume its sources in a way that doesn't guarantee the right of the future generation to obtain their fair share or from the resources. Thank you.
Thank you, Dr. Salah. And now we open discussion session about paper, two paper, the last two paper. Any questions? أنا بك. Do you have any question? Anybody has any question about the last two paper? Okay, Dr. Ahmed.
Thank you very much, Professor Khalid Behnasawi. I think we need to continue in this session because we just take two papers. So if we have some of the colleagues who is going to present tomorrow, they're available in the meeting because we lost three presenters today because maybe of the time difference or connectivity. So I would prefer, rather than closing early like this, we benefit from the time and we take 2 or 3 more presentation from ECO 3 if they are participating in this meeting right now. So I think this is okay. So either Professor Khalid, you can request, or I can take over. You advise me, please.
Yes, can you take off Dr. Ahmed?
Okay, thank you very much indeed, Professor Khalid, for moderating this session and for your kind support. Colleagues, we are going to session ECO 3 because we missed 3 presenters from the first session. And if any of the 3 presenters is around, please identify yourself and take the floor to present for us. I can call the names of Dr. Matthew Kebede from Ethiopia, Samuel Akeji, I think from Nigeria, and yes, from Nigeria, and also Aduelo Adijani George from Nigeria. Any of these 3 presenters are around. I don't see any of them. Can we call Professor Saeed Ali to give his presentation if he's around? Professor Saeed Ali, are you around, sir? Dr. Saeed Ali? Dr. Matthew, you join us? Colleagues, am I connected? Do you hear me?
Yes, we hear you.
Oh, that's good news for me. Thank you, Nali. Thank you very much. Okay, so I see now if Professor Dr. Matthews, the heavy metals analysis is around. Okay, it's really unfortunate. This is the problem when we have a virtual meeting. Sometimes we lose some of our colleagues, presenters, which we are eager to listen to them. I'm still going to share the screen before putting this session off to request any of the presenters who are around here today in the red color there, if they are ready to give their presentation or they are with us. If not, I see no hands. I see nobody identified himself. Colleagues, ladies and gentlemen.
Hamdi, just a
yes,
minute,
Prof.
Hamdi. Why
yes,
don't
Prof.
I think really what you now do really is perhaps allow for about less than 10 minutes for the general remarks, since you have a few minutes left here and perhaps those people might be coming tomorrow. So you might be very strict tomorrow, and you can see that the trend of the day is that you probably would miss one or two or three until we finish. If there is anybody with a very burning issue or something that they may wish to share with us, to specify, they may do it overall, rather than just call for a paper from somebody who may not be quite ready at this point in time. That's my thought.
I thank you very much, Chair. I think this is a very brilliant idea, colleagues. As stated by Professor Michiaka, that if there is anything you need to share with us as thoughts, ideas, before we call today meeting to be end.
Yeah, I'm the engineer. Like, for example, I have a very disturbing question about urbanization and the rate at which urban centers and cities are growing now in the African continent. And the actual clearing and cleaning and ensuring that solid waste, including the e-waste which will come later on, is going to be disposed of. Any new methodologies that countries are using so that you don't pollute, you don't have a lot of litter, a lot of hard solid all over the cities and slums and ghettos, and then end up having water completely polluted. Is there any newest technology from within the continent, or we can borrow from outside to see what can be used? That is a completely common question, common headache on solid waste disposal and management, a bigger headache than I think we think about.
Professor Michiaka, I think this is a brilliant idea because now we make it as more interactive. This is very interesting question, and I believe we need to open the floor for colleagues to comment on it, to put thoughts and ideas for the upcoming 15 minutes. We heard clearly the question that raised from the chairman of ASRIC about the solid waste, about the pollution, the e-waste, among others. And I'm not going to repeat it, not to dilute it. So the floor is open for more and more discussions and input. Please raise your hand and take the floor and let's discuss it. Thank you.
I think Hamdi, this is a mammoth question. And one day, maybe before we finish, we might want to ask, how is
Prof, there is Martin Valin is raising the hand. So yeah. Martin, how are you doing? Good to hear from you. Please have the floor, Martin.
Okay, thank you. The recovery of waste is not really technologically a problem. The challenge lies in the financing. It is costly to start a facility, let's say, for instance, to recover the gold from e-waste. Okay, for gold, that's a bad example because as soon as you have gold, you have a market. But some of the other products, you need to sell it somewhere to get your money back. So there has to be a market, and there has to be sufficient waste to produce the quantities that you need to make a profit. Otherwise, I'm afraid it's not going to work. The technology is there.
Martin, what technology is there? There is a lot of garbage. Take, for example, Lagos or even Johannesburg. You are saying that you must have sufficient produced solid waste to make cash out of it. And every country within the continent is complaining about undisposed solid waste. And they don't segregate at source. I'm not sure I understand what you're saying.
Okay. Let me give you an example. We prepared a tender for a solid waste disposal site in Mumbai. And not a small one, a very big one, 6,000 tons per day. You first of all have a challenge in collection. Then the financial model was based on the expectation that you will recover a certain quantity of combustibles, things that can burn. But those things that can burn are already taken out of the waste at street level. Even here where I live, once a week they do the waste collection. I put my bin out on the street, and then there are people who come along and they scratch through the bin and they recover anything that has any value. So the segregation is done, the recovery is done, but it is done in a certain way that does not make it financially viable for people to operate how can I say it, a competent waste disposal site, because that costs money. And collecting waste costs money, and who pays for it? And in the end, it's not the technology that floors you, it's the money. And then we get the politicians involved and everything else.
I think it's loud and clear, technology is there, but the problem is the cost implication and how we can over this cost implication in Africa. Am I right?
Yes. How can you make it work? How can you make it financially viable to do the right thing?
Is there any, let me put it like this way, is there any financial model that we can discuss here in this meeting or next meeting to come about such thing? Like,
not well, I suppose it is, but nothing that I have readily at hand.
Okay, thank you very much indeed, Martin. I think this issue of discussion need to take us more and more, and this is a good topics to be discussed during the ASRIC Congress to come, Chair. I believe the issue of water, the issue of waste and solid management, especially from the economical point of view and visibilities and the economic models and how we can make it a benefit rather than making it as a loss for our people. There are many models we need to discuss, and I believe we can request some addresses or speakers to come and address us and help us to understand more. I hope
I say something.
Yes, please, Martin, please.
Okay. When we look at wastewater treatment, we do not clean the water, but we separate the bad things from the good water. and then we discharge at a given standard the water back into our water resources. The main problem that you have is to dispose of the sludge that you have taken out of the water. I was listening to some of the presentations, and the COD and the metals and those things, they do not just disappear. They are just somewhere else, and you still need to take care of them. So any wastewater treatment must look at the final resting place of all the constituents. Thank you.
That's right. That's right. Thank you very much indeed. I think, Prof, this is a relevant thing. The discussion should be continued in the issue of waste management and solid waste management.
Yep.
I see Matthew Tissemege is around, and I would like to apologize for you. According to the work program, the name is written for me is Matthew Kebede. And that's why I went through to go directly to the book of abstracts to clarify your name. And Ekirta Matthews. And
yes,
Ekirta, your name was put wrongly in the work program. So your presentation, if you are ready with it today, it's okay. If you want to shift it for tomorrow, still it's okay for us. And I apologize for putting your name wrong in the work program. So
I suppose it's okay. It's okay. I will. It's better if it will be for tomorrow.
Okay.
I'm happy if it will be for tomorrow.
Yeah. Shigrilim Ama Signalo. Thank you very much.
Okay, I was again. Thank you.
Thank you very much indeed, Matthews, for your understanding and compromisation. Chair of the conference, Professor Abdullah Dasher, the chair of the ASRIC Bureau, Professor Michiaka. I think we did a justice for today, and I believe the discussion will take us to success stories that to be told after this conference. I believe the organizing committee has made a great job to make this happen, especially our technical teams in Cairo and in Abuja. I would like to appreciate all the efforts made by our IT officers in both sides, and also to appreciate the time being given by us by all the brilliant scientists and distinguished who are attending this meeting with us for today. And with the permission of the chairs, I would like to pronounce today's meeting is over and closed. Tomorrow meeting, we will start day 2. We have a long day to go. We have almost 8 presentations. We are going to start our meeting tomorrow by 9 a.m. Abuja time, 10 a.m. Cairo time, 11 a.m. Addis Ababa time, Min Amistad. I wish you all the best, and thank you very much for supporting ASRIC. Thank you very much for participating, and we looking forward to have you tomorrow. Keep well, be well, and safe and protected, and regards from Abuja. Thank you very much indeed, colleagues. Wish you all the best. Thank you.
Thank you.
Thank you.
Bye-bye, everyone.
Bye-bye. Shukran. Asante sana.
Good night.
Thank you.
Thank you.
Shukran.
Shukran.
Thank you. Good night.
Bye. So we meet tomorrow. Take care.
Bye. See you tomorrow.
Bye-bye. See you tomorrow.
Tomorrow.
See you tomorrow.